Get this thing off pause. Okay, so 10.1b, and that is completing the square. And if you remember back from factoring's been a while back, and that was what, chapter 6 in Hawks, that we could have things that were perfect squares, such as x squared minus 8x plus 16. And if I set that, of course, equal to 0, and we factored it, what did we find when we factored it? Well, we found out that it was a perfect square, meaning that the first term and the last term are perfect square values. And so if they're perfect square values, what do we get? Well, the perfect square of 16 is 4 and 4. But because it's a minus in the middle, I have a negative and a negative in there. Okay? So really what this is equal to is x minus 4 squared is equal to 0. And so, and another one might be x squared plus 20x plus 100, perfect square as well, because we have x and x. 100's a perfect, so it's a 10 and a 10. And the plus in the middle makes both of them pluses, and so what we find out is that we have x plus 10 squared. So far, so good? Now what makes these happen is that if you look at this middle piece, what did we do to that middle piece to get our factoring? And if we work with this middle section, that 20, what we basically did is took 20, divided it by 2, which ended up being 10, and then we squared the 10 to get 100 at the tail end. Are we okay with that part? Okay. So our process, when we start looking at these, is to go back and take a look at this thing that's in the center. And we need to take, of course, half of it, so half of 20 is 10. Take the 10 and square it, which gave me my 100 at the tail end. So that's our main process. So not all of these things that we start working with in here are, or what would we end up putting? Let's see, if I had x squared plus 6x, but what would I put at the tail end that would cause this thing to be a perfect square? What would it be? 9. Because we're taking 6, dividing it by 2, or taking half, taking that answer, 3, and squaring it to get 9, and if I put 9 back in here, I have forced it to be a perfect square. So I get x plus 3 is what my perfect square happens to be. So what did this end up becoming? Well, it ended up becoming the x squared out in front, which is a single term. It has to be a 1 in front of here in order to do this. If you have a 2 here, I can't do it until I get rid of the 2. And we'll get rid of the 2 a little bit later with doing some of those. But it's the first variable, whatever it is, x's, y's, z's, who knows. That's the first piece. Then you take the middle value. We ended up taking half of it, and that gave me the value at the tail end. Okay, so that's my 3. Then, because I squared it, that's what made this whole thing equal to this when I take and get that perfect square. Okay? All right. So, that's the kind of thing that has to happen with these. Now, how do they give you those? Well, not always is my middle something that's divisible by 2. So notice 7's not divisible by 2, but I can complete my square by taking 7, dividing it by 2, which is really 7 halves. You okay with that part? So all I did was take 7, put it over 2, basically. And what do I have to put at the end? What was it?
7 over 2?
No.
2 7.
No. What did I do? Up here, what did I do? I squared it, right? So when I square 7/2, what does that mean that I need to do with that? Well, it happens to mean that I need to square my 7 and get 49, square my 2 and get 4. So what do I really put in here? 49/4. Okay? So these kind of get a little funky at the tail end when this middle is not divisible by 2. But they're still doable because you just square the top number and square the bottom number and you got your piece. Okay? So what does the perfect square, if I factor this, look like? X plus 7/2 squared. Okay? Make sense? Hopefully. Okay. All right. Now, yeah, some of them are going to have 2 answers to them when we finally get them worked out. Yeah. And we're just figuring out the pieces that would make this thing, because we started out with this. We looked at it and we said, okay, I got to do half of the middle, so half of 7 divided by 2 is 7/2. Squared it to complete the square and make it a perfect square. And then what that would factor to would be the x from the beginning. Whatever half of that middle is, that's what I write here. Okay, so half of that center is what this n variable or this n portion becomes. And so then what we end up getting with that, and then when I square it, I get that 49/4. Okay, all right. Now, they are not all where you are given just this piece or given just that piece, but they're ones that have more pieces, of course, to them. And they may look something like this. X squared minus 8x plus 35 equals 0. Now, if we go back and we look at that, and we're back in chapter 6, if we're back in chapter 6, we would look at this and say, can't factor it. I can't come up with factors of 35 that I'm going to combine together to give me a negative 8 in the middle, can I? Any way possible of doing that? Nope, can't be factored. So we'd write in chapter 6, can't be factored, and go on and move on. All right. Now, what we're going to do when we complete the square is, if you remember, we only looked at that part last time. Remember when we just got done doing these? We looked at this piece and said, okay, what happens to this piece to make it become a perfect square? So to do that, I'm going to remove the 35 to the other side. And when I do that, that leaves me with x minus 8x equals a negative 35. And notice I left a gap in here. See that space? And you need to leave that space because now what we're going to do is we're going to force this side, make this side, we're going to force it to become a perfect square. And so I do that by, what did we do last time? Well, we took the first piece, correct? Half of a negative 8. What's half of a negative 8? What kind of 4? Yeah, signs. Okay, so half of a negative 8 is negative 4. That is going to make this side become a perfect square. What did I then have to do? Well, then I had to take that 4 that I just found. 4 times 4 is 16. So if I put a plus 16 in there, what just happened to this side? Perfect square. X squared is an x. 16 is a negative 4 because I got to have a negative 8 in there. But as always in algebra, whatever I do to one side, what else do I have to do? Yeah, do it to the other side. So I'm going to add 16 over here. So what does this become on this side? So negative 35 plus 16. What is that? What was it?
Negative 19.
Negative 19. Mm-hmm. Yep, negative 19. So now what do I have? Well, I've made this side become a perfect square. And last time we ended up with stuff that looked like this, didn't we? Seemed like we did. And maybe back in chapter 9, we had squared here and we had a negative 19 there. So what we could do with this is we could take the square roots of each side. So what happens when I take the square root of a square? Yep, parentheses disappear, so I have x minus 4. What do I do when I get a parenthesis or a square root of the other side? This is where I get a plus and minus in there, because I can't take the square of a negative 19, but it's a negative 19, so that means I take an I out, and I end up with that. Okay or not okay? And we did this last chapter. Chapter 9, I think, is where we did that, the tail end of the chapter. We started to come up with these type of things. And so then to finish it off, I'm going to add 4 to both sides. And I find out that x is equal to a positive 4 plus or minus I, the square root of 19. Well, that whole thing is imaginary. It doesn't have an exact solution or something coming out of it, but that's what I would write for this. Now in Hawks, they're going to have you write 4 plus I, the square root of 19, in one box. And they're going to have you write 4 minus I, the square root of 19, in the second box. Because these are the two answers that we can possibly come up with for that. Okay, make sense? Okay. Well, as long as that starts to make some sense, let's go through some more of these. How about this one? X squared minus 2x plus 9 is equal to 0. Can I factor that one? What does that factor? Always look to see if it does, but I can't get things in 9 that give me a negative 2 in the middle. So because of that, I'm going to minus 9, because I need to get this first piece by itself. Starting to make all these look like they come out as imaginary, but they don't. So to complete my square, I put an x. What's half of a negative 2? Negative 1. Squared. But now, remember, you got to take that negative 1 and square it and put it back in here. Negative 1 times negative 1 is a positive 1. And again, whatever you do to one side, you do to the other. So, what am I left with? Negative 9 and a positive 1 is equal to a negative 8. We okay? Yes? No? Hopefully. So, to get this by itself, square root of each side. So that leaves me with x minus 1 on the left. On the right, I can break that apart from chapter 9. I can pull out a 2 and an I. And what does it leave under my radical? A 2. And don't forget to put your plus and minus in front, because it leads us on 2 routes. Once you take that square root, you've got 2 pieces happening there. And so then, I'm going to add 1. So I find x is equal to 1 plus or minus 2i, the square root of 2. And again in Hawks, it's 1 plus 2i, the square root of 2, or 1 minus 2i, the square root of 2. And that would be my pieces that I have in there. Okay? Yes? Maybe? So far so good? Hopefully. Okay. Let's do some more. There's a whole bunch of these that we can end up working through to see what we get out of them. They give you quite a few in practice to take a look at. I'll get one that's going to come out to be something positive here. X squared plus 5x minus 5 equals 0. So on this one, I need to, what should I do? Subtract 5 or add 5 in this case, plus 5. Alright. Leaves me with x squared plus 5x, leave a space, and a 5. So if I complete my square down here, I'm going to have an x. What's half of 5? 5 halves. Take that, square it. So what's 5 halves squared? 25 fourths, yes. And if I add 25 fourths here, I also have to add 25 fourths over there. And that's where your fractions all come in, because I can't add 5 and 25 fourths, but I gotta turn 5 into fourths. So 5 over 1 equals how many fourths? 1 goes into 4 times 5 is 20. So I'm going to take 20 fourths and add 25 fourths to it. What does that give me? 45 fourths. Okay, so far so good? Okay, finishing it off, I need to take the square root of each side. Square root of this side, that's kind of easy, that's x plus 5 over 2. Square root of this side, though, that kind of gets a little more complicated, because back in chapter 9, you had the square root of 45 over the square root of 4, and we could break that apart and get a 2 on the bottom, because the square root of 4 is 2. Square root of 45, can pull out a 3 and leave a 5, because 45 is made up of 9 times 5, and since 9 is a perfect square, I can pull out a 3, and I end up with 3 the square root of 5. So down here I have plus or minus 3 the square root of 5 all over 2. We're good so far? Questions? Yes?
Is that the only answer that Hawks can accept, or is it going to be like x plus 5 over 2 equals plus 3 over 2, and then have it minus 3?
No, it's going to want it like this. It's going to, in Hawks, you're going to want to leave it like this. Because, remember, this is connected.
Right.
Yeah, so I couldn't break them apart at all. So they're connected. So then my final thing I need to do in this is minus 5 halves to get x by itself. And so when I get x by itself, I have a negative 5 halves plus or minus 3 the square root of 5 over 2. Looks kind of strange that way, but this is actually the exact same as a negative 5 plus or minus 3 the square root of 5 all over 2. And in Hawks, again, it's going to break it apart, so negative 5 plus 3 the square root of 5 over 2, or a negative 5 minus 3 the square root of 5 over 2. So it's going to break it apart. You're going to have to write, it's going to ask you for both in Hawks.
Right, not that. You can write it either way. Like,
Oh, yeah. You could put the minus first or put the other. Yep.
when you took it and you put it over the same fraction.
Yes?
You took
Oh, could you
negative
leave it
5
this
plus
way?
minus, yeah.
I think it's going to let you do that.
Okay.
I think it will let you leave it with the 2 separated, as opposed to putting it back over. The only reason to put it back over is because it's a common denominator.
Right.
So you're just basically taking your numerators and sticking them back together over 2. So, okay? All right. Yeah, so that ends up being what you end up doing with those things, and coming up with what your values would happen to be with them. And so they split out and they break apart. Now, if this would have been a 6 and this would have been a 4, we could do that triple. Remember we talked about last time doing that triple cancellation. Of course, you will see it right here. You will see that cancellation stuff right in that spot. If you're going to end up doing some canceling of anything at that point. Now, sometimes they give you things that look like x squared minus 22 equals 6x. Well, my problem with this is it's not set up into what's called standard form. And standard form is when you have ax squared plus bx plus c is equal to 0. So if you're going to work with it, you need to get it in that format. So that means I need to actually subtract 6x from both sides, so that everything is on the same side, okay, to start with. So then what would I have to move? Well, first I'm going to look at it and see if I can factor it. There's no factors of 22. They're going to give me 6. So that means I need to add 22 to both sides. And that's going to leave me x squared minus 6x. And again, leave that space because we're going to fill it in. Okay, you're going to fill it in with stuff. So make sure you leave a space in there. So if I fill this space in, what's going to happen? Well, I need to go back and do my process. Take the x. Half of a negative 6 is a negative 3. And that's the bottom squared piece. Negative 3 squared is a plus 9. And remember, whatever you do to one side, you need to do to the other. And so you're going to add 9 in there. So 22 plus 9 is a whopping 31, right? Okay. Take the square roots of each side. Once I complete or build that square. And so then I'm going to be left with x minus 3 is equal to plus or minus the square root of 31. Can't do anything with it. So add 3. So my answer from this becomes x is equal to 3 plus or minus the square root of 31. And again in Hawks, it's 3 plus the square root of 31 or 3 minus the square root of 31. So you got to put it in twice. Toughest part is getting those typed in. And be extra careful because it will kick you out if you don't put signs and you don't do certain things. I know when I was doing my certify, I lost a couple because somehow it didn't accept a sign or something with my typing happened. So double check it before you hit submit with those because it's easy to slip up somewhere and make a mistake in there. What do you think? Oh yeah. Yeah, we'll do a few more. Because we haven't even gotten in with having a number out in front, but let me find another one in here. How about this one? X squared minus 3x minus 16 equals 0. That one's kind of got a strange half piece in there. So first off, what should I do? Add 16. Leaves me x squared minus 3x equals 16. So when I break this thing apart, I end up with x minus half of 3 is 3 halves. You okay with that part? Squared on the outside, but 3 halves squared is 9 fourths. So I have to add 9 fourths to both sides. And that's when your fractions come in. So we got to take 16 and turn it into fourths. Well, 4 times 16 is 64. Then add 9 fourths to that. So 64 plus 9 is 73 fourths, I think. Should be right. You okay? Ready? Now, notice that this has a half in here. Notice this has a denominator. In your things that you're going to be working with, your denominators are usually going to be 4 because what do we always do? We take half. So if you take half of the middle, your denominator is going to be 4, which ends up being a perfect square. So that kind of helps you out with that part. So square root each side. I get x minus 3 halves is equal to plus or minus, now I got to work with this thing, square root of 73 over the square root of 4. Can I break 73 apart? Anything going 73? That's a perfect square. 3 doesn't go in there, 5 doesn't go in there, 7 doesn't go in there, 11 doesn't go in there. So all you check is your prime numbers to see if you get anything that will go in there. And it doesn't because 73 happens to be prime itself. But square root of 4 is 2. So my answer is the square root of 73 over 2. Move my 3 halves over. And I find out that x is equal to 3 halves plus or minus the square root of 73 over 2, or x equals 3 plus or minus the square root of 73 all over 2. And so that becomes what that happens to equal. Okay or not okay? Okay. always a half. So it's always a half of whatever that middle is. Never a quarter, never a third, always a half. All right? So it's always splitting it in half when you do these. Now sometimes they stick a number out in front, such as 4x squared minus 32x minus 24 equals 0. When you have a number out in front of these, I cannot complete the square if I have a 4 sitting there. Right? Can't be done. So that means to get rid of the 4, I need to divide every piece by 4. So 4 divided by 4 leaves me with x squared. 32 divided by 4 leaves me with 8. 24 divided by 4 leaves me with negative 6. And I get a 0 at the tail end. So yay, I'm pretty good so far. Can't factor it because there's no factors of 6 that add to 8, so we can't do that part. So I'm going to add 6 to both sides. And then half of a negative 8. Negative 4 squared. So what happens to that? 4 times 4 is positive 16. And add 16 to both pieces. So 6 plus 16 is 22. Take the square root of each side, and I find on this side I have x minus 4, and on this side I have a plus or minus the square root of 22. 22 is 11 and 2, which that doesn't help me. I can't pull anything out. And then finally, add 4, and find out that this thing is equal to, x is equal to 4 plus or minus the square root of 22. Yes? You won't need it. You will not need it. Because what this is when we get into looking at parabolas later on, if you calculated what this happens to be as a straight number and you did the 4 plus the square root of 22 and you did 4 minus the square root of 22, what you're finding is the x-intercepts. And on a parabola, what you would end up with is there'd be one point here and there'd be another point here, and your parabola would do one of these numbers. And so what, whoops, I'm just going to go through that point, but what you'd end up finding is where it's crossing the x-axis at, and that's what this does. This solves it and says, okay, where does it cross that point at, and what do I get out of that part? So that's the goal of what these happen to be. And that's what they were in the first section too, when we had this working with perfects, or working with taking and factoring those. So that's what you're getting, is these type of things. No, oh no, it's gone. It's gone, yeah. It's not part of that anymore for an answer. Now, later on in the chapter, when we pull out these 4s down the road a ways, then they're going to be important to us, but right now, you don't need it. It's just been an extra added thing that was put in there. Now, the ones that you got to pull stuff out of like that, that get a little bit dicey are, if I can find one. I think we had one way back here. I'll put my pages back a second. Is this one, where you have 2x squared plus 2x minus 7 equals 0. And the reason that one gets a little bit dicey is because I can't divide 7 by 2. But when I divide everybody by 2, I get my x squared, I get plus x, and I get a minus 7 halves is equal to 0. All right? So what has to happen with this thing is I add 7 halves to both sides, just like I've been doing. And I have, whoops, x squared, my colors here, plus x is equal to 7 halves. So far, so good? Okay. Half of 1, so that means inside of my parentheses that completes the square, I really have a plus 1/2 squared. Square my 1/2, so I'm going to add in here 1/4. And when I do that, I also have to add 1/4 over there. That's the only biggie here, is because what happens to this is I need to take that 7/2 and make it into fourths. 2 goes into 7 twice, or 2 goes into 4 twice, sorry. And then 2 times 7 is 14. So my answer comes out to be 14/4 plus 1/4 is really 15/4. Okay? Yes? We're good? Hopefully? Okay? Because this one ends up being the more complicated one. Then if we take the square root of each side, that leaves me with x plus 1/2 is equal to a plus or minus. And when you get this, this is 4 again. It's kind of always, it can change in here though, because, well, no, it really wouldn't. It's still going to be 4, regardless of what you do. So it's really the square root of 15 over 2. And subtract a 1/2 from both sides. And I find x is equal to a negative 1/2 plus or minus the square root of 15 over 2, or x is equal to a negative 1 plus or minus the square root of 15 over 2. Okay? We good? Or you need another one? Another one? No? I'm not hearing anything out of you. So I think we're good? Thumbs up? Okay. Good deal. All right. So that's... Shoot. I probably missed a whole section in here. But anyway, that's the thing that we have going on with those. So I've probably lost a whole bunch of my recordings. I hate that when that happens. So moving on to 10.2, which is the quadratic, that arrow up there. Well, pause it again on me. We're moving into the quadratic formula. And usually everybody kind of likes this one because it's a system, it's a pattern you can use of plugging everything into the formula and kicking out an answer when you get it. The thing about this that you have to have in place when you're working with it is that all of your equations, so the equations need to be in standard form. So you got to go in standard form. Standard form means I have ax squared plus bx plus c is equal to 0. So when it's in that format, that's what's going to let me pick out my pieces that I need to work with my quadratic formula. And the quadratic formula happens to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's always going to kick out whatever your variable happens to be of x or y or whatever they happen to put in there. Usually it's an x because, again, this is leading me to my x-intercepts within my parabola. And so that's the piece that I end up having in there with that. Now, in Hawks, in your instructions, they do go through and show you how this came about. And it came about by just simply doing the stuff that we did in that last section, getting x squared by itself by dividing everything by a, moving then your CA over and doing some other stuff and coming up with common denominators and so forth. But this ended up being the formula that we end up using for these. And the reason you guys like it is because you don't have to worry about manipulating anything. You don't have to look for perfect squares. You don't have to look for factoring. You just find out what A is, find out what B is, and find out what C is, plug it in here, and end up solving it. Okay? Now, under this piece alone, right here, this b squared minus 4ac, and that is called the discriminant. And the discriminant, what it does for us, it tells us some information about our x-intercepts. It tells us whether the parabola touches the x-axis, whether it touches it in two places, whether it touches it in one place, or whether it doesn't touch it at all. And so how that happens is that if b squared minus 4ac, when you plug in b and a and c, is greater than or equal to 0, or greater than 0, sorry, get my equals out of there. If b squared minus 4ac is greater than 0, there will be two answers. And in Hawks, it asks you to do this, and we'll talk about that a little bit when we get into solving some of these. There will be two answers, meaning that if we went back to one of these ones we just got done doing, if I took a look at this one, for instance, this is the discriminant. The 73 that's under here, that's the piece that we were just finding in here. And because there is a 73 and it's bigger than 0, I ended up taking this and writing it out into two separate answers. Okay? If it were imaginary, and that's kind of how we started this whole thing out, if it were imaginary, let me find my imaginary one. If it were imaginary, it never touches x. So, in this case, if b squared minus 4ac is less than 0, there are two imaginary numbers, and the parabola does not touch the x-axis. So it's kind of floating. So what this parabola would look like would be something on that order. It still can be a parabola. We can still have a graph of it, but it's not going to touch. Where this one up here, if we were to graph it, the parabola would be doing one of these numbers and would be touching at 2 points in there. So it would have a spot and it would touch in a certain value in a certain area. And so that's what we have happening here. And then finally the last one, if b squared minus 4ac is equal to 0, there is only one answer. So the parabola only touches x in 1 point. Okay, so it's only going to touch in 1 point. So that graph of the parabola would look like this, where it comes down, touches it once, and keeps going. So it only hits it at one spot. So that's what the discriminant does for us. And the discriminant is probably the tougher piece of this whole formula to end up solving, because everybody can multiply 2 times a, and everybody can make negative b. So it's this piece that can be the one that creates your problem for you. Okay, so everybody got this so far? Whoops. I'll let you keep writing. Sorry. Okay now? Okay. So let's put one up here. So if we had x squared plus 2x plus 1 equals 0, if we were back in the last stuff we just got done talking about, of course we would subtract 1 and get x squared plus 2x equals negative 1. We would take half of the 2, which is 1. We would add 1 and get 0. Plus or minus. Correct? And so, what would my answer be? Well, I just minus 1 from each side, and I get x is equal to a negative 1. And that's all I could possibly have, because this side came out to be 0. If you look at the quadratic formula, it's a negative b plus or minus the square root of b squared minus 4ac all over 2a. in my online class, there is a video that gives you a song that goes with that. And if you'd like, I can post it into your page, and you can have the song to sing if you want. It's kind of hilarious, but anyway, that gives you this piece, because you do need to know that formula and know how it works. So if I go back to this problem, a is what's in front of the x squared, so my a is equal to 1. My b is equal to 2, because that's the middle term, and my c is equal to 1. And so then if I plug it all into this formula, this negative in front of b is a negative 1. So if I plug in a positive 2 in for b, I still have minus 2. If I plugged in a negative in for b here, that would become a plus, okay, because it's a negative 1 times the negative number you're putting in for b. So the sign changes. And so under here, I have 2 squared. So I'm plugging in for b, minus 4, a, which is 1, c, which is 1, all over 2 times 1. Okay? So far, so good? So then if I go through and solve this, and usually what I do is I just take that and I go right up above here and work out my pieces. Or you can take this whole piece and stick it on your calculator. That might help you out. But don't put the square root symbol in there. All right, leave that piece out. Just solve what's underneath. So 2 times 2 is 4. Negative 4 times 1 is a negative 4. Negative 4 times another one is another negative 4. So then I do my math in here. 4 minus 4 is really 0. And it goes back to that rule, because that was my discriminant under here, was equal to 0, so therefore there's only one answer. 1 times 2 is 2. And finally I'm left with a negative 2 divided by 2, or a negative 1 for my answer. Okay? Just like I found over here. So I don't know. Some people think this way is a lot easier than this way. And this way does get easier when you start getting other numbers in front of here and trying to do stuff with that. But it's just the same answer. So it works out exactly the same as what we were doing before. So another one. How about this one? Get something that's got some numbers in it. Negative 6x squared plus x plus 3 equals 0. So Hawks will break this thing apart, and one question will be, what are your A's, B's, and C's? And again, when you're doing these, make sure you write those out so that you know which is which. So A is a negative 6. B is what? What's B in this case? 1. And what is C? Positive 3. Okay. So A is a negative 6, B is 1, and C is 3. So then I just go and plug all my pieces in. Hawks may say, what's the discriminant of this? So the discriminant means I'm only going to work with the b squared minus 4ac. So if I do that, I'm going to put in 1 squared minus 4 times a negative 6 times 3. And what's going to come out of that? Well, 1 squared is 1. Negative 4 times negative 6 is a negative 24. And negative 24 times 3. Or positive 24, I should say, times 3. What's that going to give me? 3 times 4 is 2. Carry my 1. 3 times 2 is 6. 72? Okay. So then, 1 plus 72 is really 73. And so what would this say? Now, in Hawks, it will say 1 solution, 2 solutions, or no solutions, and it's going to be a 2 solutions because it is larger than 0. So you'd pick 2 solutions. And then the next piece is plug it into the rest of it. So it's going to be a negative 1 plus or minus the square root of 73, because that's what's underneath this radical piece, is that discriminant. So I've just found that piece, all over 2 times a, which is a negative 6. And so what do I get for an answer? Well, it's going to be negative 1 plus or minus the square root of 73 all over a negative 12.
Where did you get the negative 1?
The negative 1, it's a negative b. okay? And so when you replace b, you're replacing b, not the negative 1. Okay? That makes sense? Okay, good. Let me move it up. Okay. So that would be my answer. So if it asks you in here for the discriminant, you would end up solving that first. If it asks you to identify the letters, you would end up doing that. And then down here is to finish it. And to finish it, you'd end up plugging it in and coming up with your answer. Now, is Hawks going to be happy? What do we all know about Hawks? Is Hawks happy when we get a negative in the bottom? No. So what we'd have to do is multiply top and bottom by a negative 1. So really my answer is 1 plus or minus the square root of 73 all over 12. Okay? So they want some sign changes happening in there to get that. So
last section you had to write 2, it would be like 1 plus square root of 73 and 1 minus 73.
yes, yeah, they still do that in here. So it's 1 plus the square root of 73 all over 12 and 1 minus the square root of 73 all over 12. Yes, yeah, but be careful because in the last section of completing the square we need that a little later on. So make sure you practice it, but you can use that same thing with those. It's a good way to know whether you did it right. Yep, with that. But again, we do use those techniques for completing the square in the other ones. So how about this one? Negative 8x squared minus 5x minus 2 equals 0. Now this one would not be fun to use completing the square on, would it? I see why. Divide everybody by 8. It's kind of ugly because I get 8/5 and I got to take half of 8/5 and things get real ugly with this one. So I wouldn't want to complete the square with this. And I can't factor it, so I have to come up with something that's going to work. So then in this case, A is a negative 8. What's B? Negative 5. And C? Negative 2. Yep. And so always identify those, even if Hawks doesn't ask you for those, because it's so easy to miss up on something and miss a sign when you're plugging it in. Okay, so then if I plug that into a negative b plus or minus the square root of b squared minus 4ac all over 2a, if I plug that in, when I put the negative 5 in for b, it's a negative 1 times a negative 5 or a positive 5. Alright, so be careful with that part, that you don't miss that. It changes the sign because it's a negative 1 times b. So when I put in negative 5, negative 1 times negative 5 is a positive 5. So be real careful with that part. And then the second part is negative 5 squared minus 4 times a negative 8 times a negative 2 all over 2 times a negative 8. So what comes out of all that good stuff? Well, negative 5 squared is 25. Negative times a negative times a negative, I'm going to get a negative. So something weird's going to happen there. Negative 4 times 8 is 32, times 2 is 64. So what is under there? So I have 5 plus or minus the square root of 25 from 64. What's 25 from 64? Negative 39. Okay. And 2 times negative 8 is a negative 16. But I'm not done because this is imaginary, so it's a negative 39 under there, which means I never is going to touch. That parabola will not touch the x-axis at all. And so I get 5 plus or minus I, the square root of 39, all over negative 16. But Hawks isn't going to like negative 16 in the bottom. So multiply top by negative 1 and the bottom by negative 1. When I do that, negative 1 times 5 is negative 5. This plus and minus is just going to reverse everything anyway, so you don't have to worry about that piece. And a negative 1 times a negative 16 is a positive 16. And then finally Hawks wants to have this written out as 2 separate answers. And you get that for your answer. Okay? Make sense? Yes? No? We good with putting those things in there? Again, it's just the formula, so you're just going through and finding your stuff in there. Now, sometimes they give you ones that are not written in standard, so you got to get them there. So if we have 7x squared minus 1 is equal to 2y. Not in standard form. Need to move the 2y back over. So that leaves me 7x squared minus 2y minus 1 equals 0. And then I identify my A's, B, and C. And again, I can't stress that enough. Make sure you do that. Okay? Don't just say, oh yeah, I can do it, I don't have a problem. Because what happens is you pull out wrong things. A is 7, B is a negative 2, and C is a negative 1. So keep your signs in there. So make sure you do that when you get those. And then what we're going to need to do is on this one, we are going to need to plug it in. So it's a negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you write that every time you do one of these, you'll start to remember it. Okay? So you want to write it now. I'll see about posting that YouTube video with the song with that. So in this piece, plug in my pieces. Negative 2 goes in for b, so really I have a positive 2. Negative 2 squared minus 4 times 7 times a negative 1 all over 2 times 7. So what do we get? 2 squared is 4. Negative 7 times, or negative 4 times 7 is a negative 28, times a negative 1 is a positive 28. So really I have 2 plus or minus the square root of 4 plus 28 is 32 all over 14. But from chapter 9 we've learned we cannot leave this the way it is, right? So what does that have to become? So it has to become 2 times 16, I think, right? And 16 is a perfect square, so that means I can pull out a 4, leave a 2, and put it over 14. Then what do you notice? Hawks will, if you put that into Hawks right now, Hawks will come back and tell you it's not reduced, right? So that means I can do my triple reduction. This and this and this all have a 2 inside of those. So my true answer is 1 plus or minus 2 to the square root of 2 all over 7. And then in Hawks, of course, they want it broken out. So 1 plus 2 to the square root of 2 over 7 and 1 minus 2 to the square root of 2 over 7. Okay or not okay? We good or not good? What do you think? Another one, or are you okay? Good? Okay, because basically, again, it's that formula, making sure that you write out your A's, B's, and C's. Don't skip that part, because that's where you can make a mistake and it costs you down the road with some stuff. Okay. So now we have the favorite of all favorites, 10.3. 10.3 is applications. And in Hawks, of course, it gives you a bunch of different varieties of application problems, and I put some of them on a sheet. So we'll go through each of those and get the ins and outs of what we have to look for them. And sometimes you get a pattern going with them that you can start seeing some things. So when you do these story problems, make sure you read the problem carefully. get the gist of what it's talking about. What is it a club that's doing something? Is it two companies working together? Is it shape like a triangle? Because we're going to get into triangles with this, because we can use the Pythagorean theorem to do some stuff with completing the square or doing the quadratic formula. And basically we're going to use quadratic formula to solve all these. And sometimes the numbers are pretty big. So you're definitely going to want to use your calculator with them, because you end up having to work with those. And then the second step is decide what it asks. You to do. Step 3 is create a formula to solve it. Some of these have a formula. They'll give you one already, and you just need to plug in your numbers to end up solving them. Step 4 is form the equation. So you're going to create an equation. In step 3, you also might want to do something with charts, because some of them are not distance, but they're airplane flights, and so you have headwinds and tailwinds and that type of stuff that fits into that. Step 5 is solve it. And when we solve these, we're going to use the quadratic formula, because it makes it a whole lot easier. And then finally, step 6 is check. Because you're going to get 2 answers with most of these, you're going to have to go back and take a look and say, okay, which one of these answers are we looking at? Especially if you're working with a triangle, you're not going to want your negative answer, because we can't have a negative side. So you want to make sure you take that part and do a check with those and see what you happen to have. When you look at right triangles and the Pythagorean theorem, the Pythagorean theorem is looking at a squared plus b squared equals c squared. And in other words, a leg squared plus a leg squared is equal to the hypotenuse squared. And the hypotenuse is the angled side or the longest side. So it's going to be longer than the other. The legs create the triangle or the right angle. So if we had a triangle connected with this, a right angle is in here, a leg is here, and another leg is there, and a hypotenuse is over here. And so this was based in 500 BC was when Pythagoras created this theorem. And when you look at that, 500 BC, so 500 BC is before Christ. So you're looking at this formula being around probably about 2,000, maybe 600 years, something on that order, of being around. And so it's an old thing, and it still works. A lot of times they used it in surveying before we had transits and different things that shoot a beam across to measure stuff, but they'd set up triangles to measure different lengths and different stuff. So it was been around an awfully long time. So the question that they give you in Hawks of the story problem that goes with this is similar to this one that's down below here. It says the width of a rectangle is 7 yards less than its length. And you're thinking, but wait a minute, that's a rectangle. That's not a triangle. But what makes it a rectangle is if the diagonal measures 13 yards, what are the dimensions of the rectangle? So what this really means is that if I have a rectangle like so, a diagonal means I'm taking that rectangle and splitting it right down the middle. And when I split my rectangle in the center like so, what happens to it? Well, it makes 2 triangles. So what do I know from the information I have up above? I have find the rectangle, or the width of a rectangle 7 yards less than the length. So what that means is here's my length. What's my width? Is 7 yards less, so that means length minus 7 will give me my width. We okay? So far so good? Okay. So then, because the diagonal that creates and separates these two into two triangles is 13, now I have my hypotenuse, a leg, and a leg. So now I can plug it into my formula. And my formula happened to be a squared plus b squared equals c squared. So the leg squared plus the leg squared is equal to the hypotenuse squared. And so if I multiply all that out, I'm eventually going to end up with a quadratic equation from this. So what's this squared? What's L minus 7 squared? So really, that is L minus 7 times L minus 7. So L squared, 7L and a negative 7L is a negative 14L. We okay with that part? Or do you need that written out? L times a negative 7 is negative 7, and negative 7 times L is another negative 7, or negative 14. 7 times negative 7 is a plus 49.
Would it be L squared?
Oh, it should be L. Thank you. Yep. Getting my L's in there, thinking X's instead. And then finally, L squared is just plain old L squared. And 13 squared is 169. So now I can combine some stuff together in here. L squared and L squared is 2L squared. Minus 14L. And if I subtract 169, because I need to get this set equal to 0, I end up with a minus 49 from 69 is a minus 120. You okay with that part? We good? Okay. Equals 0. So now I have a quadratic equation, and I have some choices I can make. One choice is that I could factor it, but I don't think it's going to factor very well. I could complete the square. Not bad to complete the square, because I can divide everybody by 2 and do it that way. Or I can use the quadratic formula. And most likely you guys are going to pick the quadratic formula, yeah, because it makes it a whole lot easier. So A is 2, B equals a negative 14, and C equals a negative 120. So notice my numbers get pretty fair size in here. So let's go and see what we can end up with for my answers to this thing. So if I plug it into my quadratic formula, I'm going to have 14 plus or minus the square root of a negative 14 squared minus 4 times 2 times a negative 120 all over 2 times 2. And what is that? If I stick it all on my calculator, what happens to that thing? What values am I going to end up coming up with if I do that? Let me stick a blank sheet of paper under here. A little more writing room that way. So what does that end up working out to be? What was that? You can put that whole thing in your calculator. Fantastic, huh? So if I square my 14, well, let's see, what did that become? I think I have that one. I put my page to solve it. Where I put the rest of my solving. Oh, I didn't. I guess I didn't finish it out in my sheet. So what happens? Well, I get 14, negative 14 squared. I get 2 times 4 is 8, negative 8. Negative 8 times 120. That's where they get really big in there. So what comes out of this piece? What was it? Can't be. 1,154. 64. 1,164 is what you have under there. Anybody else agree? Or are we not agreeing on what we could possibly have under there? So if I work that out on my calculator, I would take, if I can find my spot here, 14 squared 2. 14 squared minus 4 times 2 times a negative 120 equals, it's 120, not 121. Yep, that gives you something different. So really underneath there I have 1156. So then I go second, square root, second, and if you don't want to type that 1156 back in, you go second on your calculator, go down to your negative sign, and it will put your answer into your square root, close it in a parenthesis, hit enter, and I get 34. So really, out of this whole thing, I have 14 plus or minus 34 all over 4. So what could my length possibly be? Well, if I take 14 plus 34, put that back in there, 14 plus 34, I get 48. 48 divided by 4, I get 12. Yes. Okay. So L could equal 12. What also could L equal? Well, I could take 14 minus 34, take that and divide it by 2 and get a negative 10. But what's wrong with a negative 10? I can't have a negative length, right? And so my answer is 12. But it says, what are the dimensions of the rectangle? So am I done? Basically, all I have is this side, which is 12. But what's this side? 12 minus 7. And when I take 12 and minus 7 from it, I end up with 5. So my width happens to be 5. Now be real careful when you are putting these answers into Hawks, because it will say length and it will say width, and if you put 12 in for width and 5 in for length, it will give you the wrong answer even though you have the right answers. Okay, that happened to me a couple times. So be real careful with that and make sure that you put your right answers in the right spot. I just wasn't reading carefully enough, I guess, when I was doing those. Okay or not okay? So to recap it, we had to draw our rectangle, we had to put our dimension in there, or a diagonal that broke it into 2 pieces, put our sides together, use the formula, which was the a squared plus b squared equals c squared, and work the whole thing out to come up with what I had. Alright, next one on there.
How did you get 48?
How did I get 48?
Yeah.
14 plus 34.
So are you always going to add that? Okay, so you never minus it.
No, unless it said get me negative answers. But in this one I'd never do the subtraction piece because it doesn't make sense, especially if this is bigger than that.
Okay, say like if it was 34 and then positive negative 14.
Then you would do both routes because you'd have 2 positive answers. Okay, because you would have 34 plus 14 and 34 minus 14. 34 plus 14 is 48, and 34 minus 14 would end up giving you still 20. Okay, so they both be positives, but it doesn't normally happen with this variety to get 2 answers. Okay, next one. The next one uses a formula. It says a bullet fired straight up from 6 feet above the ground level with a muzzle velocity of 340 feet per second. When will the bullet hit the ground? Use the formula of this and come up with what we're supposed to have. Well, the formula that they have for velocity is negative 16t squared minus the velocity. So the velocity is going to be 340. So I have h is equal to a negative 16t squared minus 340t plus the height of where you were at. So the height is 6, and so that becomes my equation that I happen to have, or my quadratic that I would need. Be careful and watch for velocity and height is what you've got going in there. It kind of gets a little confused, but you'll see velocity in there. That's why on New Year's Eve in this country, there's those traditions of going out and shooting your gun off on New Year's Eve. I don't know if you guys ever heard of that. People go out in their neighborhood and shoot off any gun that they happen to have. But what happens is somewhere, and this has been proven in neighborhoods, if there's big neighborhoods, people have gone off and shot their gun, and the next thing they know, the next day they hear somebody died because the bullet has went up and ended up coming back down, and ended up, that person happened to be in the right spot at the wrong time, and the bullet hits them. So not a good idea to shoot your gun off in the middle of the night up in the air.
Unless you live in the country.
Yeah, you might kill a deer, huh? No. Yeah, but in a city, not a good plan, okay? Because it has to come down somewhere. So in this one, what would we do? All you'd simply do is plug these things into your quadratic formula and kick out an answer. I don't think we need to do that, do we? Or do you want to do that? Do it? All right, well, let's plug them in because we got some big things in here. So A equals a negative 16. B equals a negative 340. C equals 6. So, put it in my quadratic. So I have a negative 1 times B, or a positive 340, plus or minus the square root of a negative 340 squared minus 4 times a negative 16 times 6, all over 2 times a negative 16. So that's my quadratic. So again, handy dandy calculator, make sure you have them, because you are definitely going to need a calculator with this section, because your numbers are pretty big.
If we wanted, could we do the square root of negative 340 to the power 2 minus 4 times 16 times 6 all over 2 times negative 16? Would the equation come out correctly in the calculator?
It should. It should, but just be really, 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 really careful, okay, that you make sure you put stuff in. If you're going to put it all in, the question was, could you put the whole thing into your calculator? Because what do we know? We know we need to have a positive route, okay? So if we did and stuck it...
We didn't put 340 in there as well, just the second part of the equation.
Right.
Okay.
But don't divide this by this, okay? Because if you divide this by just that piece, you're missing a section.
Right.
Okay? But if you went on your calculator and said 340 plus the square root of a negative, or you gotta put that inside of parentheses, negative 340 squared minus 4 times a negative 16 times 6, close that in a parenthesis because that's your whole stop part on the top. I would hit enter at this point first and get your answer. Now, why did I get a decimal? Did I have a decimal? I'm thinking maybe I didn't have a decimal. No, I think it does work out to be a decimal. It'll tell you in there to round to a certain spot, and I think I just missed my rounding in there. So that's the top part. That's this piece, this here. But then I got to take that and divide it by parenthesis 2 times a negative 16. Now, the problem with this one is I get a negative answer. Can I have a negative answer? Okay. So going the positive route wasn't really the route I needed to go. All right, but if I've got this all on my calculator, if you go second, hit enter, and bring back that square root part that we had, then all I need to do is go up above and go over and change that to a subtraction, hit enter, and I get my new answer. Okay? Yep, but then when I take that and divide that answer by my 2 times the negative 16, oh wait a minute here, gotta back that up, I'm gonna put that inside parentheses. Parenthesis, then I get that for an answer.
It's almost just easier to break it down.
Yes. Yes, it is. Yep. So in this case, what it's saying, if you're hitting above the ground 6 feet and you are going to go and shoot that gun off and you're going to head it up into the sky, it comes down pretty doggone fast. Because what does it come down in? 0.02 seconds. So not very long, okay? So that ends up becoming the part that you have with that. So be real careful with those. But again, playing around with these bigger numbers, just be aware of that some of those do end up getting some fair-sized stuff in there. Okay, so that's 2 of the variety. The next one is the ski club is planning a charter bus to a ski resort. The cost will be $900 and each member will share the cost equally. What does that mean? What does that first sentence mean? What was that? What equals 900? The full cost is $900, but when you said that when we say it's divided by each member is sharing the cost, how many members do I have? Do I know? Not right now, I don't. So let's keep going. It says at the last minute, 15 more members decide to go on. Whoops, I need an O in there. The trip. The cost to each of the members will be $10 less. How many members are going to the ski resort now? Well, what this really means, if we look at it, is that $900 is divided by the number of members, correct? We understand that part? So if the members were 10, they'd pay $90 a piece. If the members were 9, they would pay $100 a piece. So then what ends up happening is 15 more members decide to go on the trip. What does that do to my X? It makes an addition, right? Because 15 more members are going. So what happens? So now what gets divided by that? Still a flat fee. The trip's going to cost $900 regardless if one person goes or 60 go. So what that means is now I have the 900 divided by X plus 15. We okay or not okay? Okay. But what does this mean? Well, it's going to cost them $10 less. So what happens to these two things? Well, what happens is the 900 divided by X plus 15 lowers the cost for each individual person by $10. So what happens here, whatever this was, gets lowered by $10. So then what has to happen is then you have 900 over X is equal to $10 because there's a difference of $10 between those two. And so when you set these up, you got to think in fractional values because it's the total amount divided by how many members. And so when you get that total amount divided by how many members, that's the key piece in there, is that you want to make sure that you get it divided by those members. So how do I solve this? How do I get it to a quadratic equation? So I've got denominators here, so I need to clear those out. That goes back to chapter, what, 8? Somewhere in there. Or 7, I guess. No, it wasn't 7. Yes, it was 7. I need to clear it out, so I need to multiply by X plus 15. I need to multiply by X. And I need to multiply by 1, but is 1 going to change anything? No. So what does 900 get multiplied by? Well, it's already over X plus 15, so I just need to multiply it by X. 900 in the second one gets multiplied by X plus 15. And finally, what does 10 get multiplied by? 10 needs to get multiplied by the whole works because it has a denominator of 1. And then I do my multiplications. 900 times X is 900X. 900 times X is a negative 900X. 900, negative 900 times 15. Oh, that's a good old calculator issue. 900 times 15 gives me a negative 1,300 or 13,350. It's for the numbers to get big in here. The second piece, 10 times x is 10x times x plus 15. 10 times x is 10x squared. 10x times 15 is a plus 150x. Put these together, 900x minus 900x is long gone. Minus 13500 is equal to 10x squared plus 150x. Move this over. And I find 0 is equal to 10x squared plus 150x plus 13500. And so that gives me my A's, B's, and C's out of this thing. They're big, so keep that in mind. So then what do I have to do? Just plug these into my quadratic formula and I will get my answer. Okay? So will I want the negative answer? No, I want the positive answer. And so this is going to get me back to how many people attended this whole thing. If you want to make your numbers a little smaller, 10 will go into each of these. So you could have 0 is equal to x squared, divide by 10, divide by 150 by 10 and get 15, divide 13,500 by 10 and get 1,350. It makes it a little easier to work with, but you can reduce it that way. And I think we're okay putting in the quadratic. Mainly getting these things set up is the biggest problem with that. Okay, yes or no? What do you think on that one? You run across these, there's probably at least 3 of them that pop up when you do your certify. This one, Franklin's have a rectangular swimming pool that is 8 feet longer than it is wide. So what in the world does that mean? Yeah, that means I got a rectangular swimming pool that is 8 feet longer than it is wide. So W plus 8 and W. We okay with that part? Yes? Maybe? Okay. And it says the pool is completely surrounded by a concrete deck that is 7 feet wide. The total area of the pool and the deck is 1,678 square feet. Find the dimensions of the pool. So what that means is out along the outside edge of this pool, there's a deck. And that deck is 7 feet wide. Every direction it's 7 feet wide. So what does that mean for the dimensions of my outside of this whole thing? Well, it means I have an extra 7 feet here and I have an extra 7 feet there. So what is this length of my pool? I have 7 feet here and 7 feet here and W plus 8 in the middle. What's the length of that whole side? So add them all up. 7 plus W plus 8 plus 7. So 7 plus W plus 8 plus 7. And out of that I get W, which I can't put with anything. 7 and 7 is 14, and 14 plus 8 is 22. Is that right? I think so. Plus 22. And same thing happens with my width. It's 7 feet up here and it's 7 feet down there, so it's 7 plus the width plus 7 to give me its dimension, so W plus 14. Okay or not okay? Then, because I'm dealing with area, what's the formula for area? Area equals length times width. So the area is 1678 is equal to W plus 22 times W plus 14. And then you would come up with your quadratic equation out of that. So I have 1678. W times W is W squared. 14W and 22W is 36W. 22 times 14. 308, yep. Okay. And to get it set equal to 0, I'm going to minus 1678 from both sides. So on my calculator, I'm going to minus 1678 from what I had on there, and end up with a negative 1370. And then what would I do with that? Factor it if I could, but I can't. So I'm going to go back with my quadratic formula and end up plugging my numbers in. We okay or not okay?
Is that 36 or 360?
What, this one? Is 360W.
Because on top it looks like 36. I was just rolling it down.
Oh, yes, it should be 36. Thank you. Yes, yes, yes. Yeah, it's 36. Whew. Bringing down the wrong things. Thank you, Brooke, for pointing that out. Yeah, I'm bringing down an extra 0, which I shouldn't have. So, yeah, it's just 36. W with that one. Yep. And so, I think you're okay with putting in a quadratic? Yes or no? Yeah? Okay. Good deal. Well, we wiped off another couple there. This one. Find the negative real number. Negative meaning when I get to my final answer, I want to use the negative piece of this thing as opposed to the positive piece, such that the square of the sum of a number and 20 is equal to 25. If there are two correct answers, either answer will be entered. So what did it say? It says square the sum. What's sum mean? Sum means to do what? What are we going to do if we're going to get the sum of something? We're going to I was going to say, I'm beginning to think out there that something happened. You guys didn't remember what you're supposed to do. The square of the sum of a number, so x plus 20, square that is going to equal 25. Now you'd probably look at that one and say, what does it look like? We've had these guys before. What do we do to them? When I've got a square on this side and a number over there, what do? Simply take the square root of each side. Yeah. So if I take the square root of this side, I get x plus 20. If I take the square root of that side, I get a plus or minus 5. So I got to get x by itself, so I'm going to minus 20. So I find out x is equal to a negative 20 plus 5, or a negative 20 minus 5 when I work out my two pieces. So negative 20 plus 5, good old negative 15. Negative 20 minus 5, negative 25. And both are negative, so what this statement says, I could put either one of those in for my answer. I don't need to put both. So I could put either negative 15 or I could put in a negative 20, whichever, or 25 I should say. So whichever one I want to stick in there would be my answer. Okay? All right. Two companies working together can clear a parcel of land in 8 hours. So what does that mean? Company A and Company B are working at the same time. We've had these work problems. You guys remember these work problems? They were back in chapter 7, I think. It's been a little while since we had them, but whenever we had work problems before, we came up with what they could do in a single hour. What fraction of that job they could do in a single hour. So if the two are working together in 8 hours, that means in each hour they can do 1/8 of the job. We okay with that part? Okay. Working alone, it takes Company A 4 hours longer to clear the land than Company B. So Company A and Company B, what do we know about those? Company A, it says it takes Company A 4 hours longer to clear the land than Company B. So who do I not know a thing about? B. So we're going to make it X. Okay. What do I know about Company A? Just takes them 4 hours? 4 hours longer. What does that mean? Than company B. Yeah, x plus 4. Yep. And so if I set each of these equal to this 1/8, it's going to be this company, if it worked all by itself, and it would take it 1 over x plus 4 hours to do it the job all by itself. But we're going to add company B to it, and company B takes 1 over x amount of time to do that one. And so it's kind of like that one problem we did a little bit earlier, because I've got fractional denominators. You okay with that? See fractional denominators? So to clear those out, I need to multiply by 8, and I need to multiply by x plus 4, and I need to multiply by x. Everybody gets this whole piece. So if I multiply it by the 1/8, the 8 cancels out, leaving me with x plus 4 times x. We okay with that part? X plus 4 times x. If I multiply it by the second piece, the x plus 4 cancels out, leaving me with 8x times 1. If I do the last piece, I've got an x, so that cancels the x piece out, leaving me with 8 times x plus 4. And that's going to give me my quadratic equation with this thing. So x times x is x squared. 4 times x is 4x. And 8x. 8 times x is 8x. And 8 times 4 is 32. We all right with that part? Okay. Put everybody together. 8x and 8x is 16x. But I need to get it set equal to 0. Since x squared is on the left, I'm going to move everybody else to that direction. And what am I going to be left with? X squared. Positive 4 and a negative 16. What was that? Negative 12. And a minus 32. Is equal to 0. And then I would pull and put this thing into my quadratic equation and get my answer out of that. Now, because it says up here, how long would it take company B to clear the parcel land? B, remember, we associated with X, so when I get this answer, that's going to be what I need for my answer. Okay? If it said company A, I'd have to plug it back in and add 4 to it, or whatever it come out to be. But if we plug this in, A is 1, B is a negative 12, C is a negative 32. And so then if I plug those into my formula, I have 12 plus or minus the square root of a negative 12 squared minus 4 times 1 times a negative 32 all over 2 times 1. And then from there, I think you're okay. Correct? Okay. Good deal. Let's see. We did a hypotenuse one, so you guys think you're okay with that one? This one gives me the square root of one of the legs. So when I square that, what am I going to end up with? When I square the square root of 27, I just get 27. Okay, so be careful with that one. The next one is a rock climbing group again, and so if I rock climbing group, you are going to do the exact same thing we did before. You're going to take the 1800, divide it by the number of climbers, and then 10 members decide not to go. So what does that mean if they decide not to go? Yeah, that means 1800 divided by x minus the 10. So there's a little difference there. But still it's a subtraction, because you're still getting the difference between those, and the difference happened to be $90 was the increase. So these guys had to pay more money than what they originally had to pay at the beginning. They're probably mad at those 10, aren't they? I'd probably be upset with them too. One last one, and I know I've got a lot of extras in there that go into your packet that you have with these, and they're ones you're going to run across. But let's take a look at this rectangular auditorium here. It says a rectangular auditorium seats 1,900 people. The number of seats in each row exceeds the number of rows by 12. So we have seats and we have rows. What do I know about each of these? What one don't I know anything about? Is there one of them that I don't know anything about? The number of seats in each row exceeds the number of rows by 12. I don't know how, that's the least one I know about is seats, or is the least one I know about rows? All right, we got you two battling back and forth here. Why do you think it's rows, Brooke?
Oh, it's seats because it has one of the lists.
I picked you because you were right. The number of seats in each row exceed the number of rows by 12. Rows we don't know anything about, but seats we know it's rows plus 12. Okay, so we've got two pieces going in there. And it's a rectangular auditorium, so if we use seats as our base, it's going to be seats times rows is going to give me the number of total seats that I would have in there. So 1,900 is equal to R plus 12 times R. And then that will end up getting you your quadratic with this one. So be real careful. It makes you think it's seats because of the way they word this.
So it's actually 1,900 equals R plus 12.
Yeah, let me rewrite that so it looks a little neater. 1,900 is equal to R plus 12 times R. Yep. And then you get a quadratic, and then you get it into your quadratic formula to end up getting your answer of what you happen to have with that. I didn't do a plane one, so I guess we better set up that one too because you run across these. A plane travels at a speed of 165 miles per hour in still air. Flying with a tailwind, the plane's clocked over a distance of 725 miles. Flying against the headwind, it takes 2 hours more time to complete the return trip. What was the wind's velocity? This one is the distance equals rate times time, and we've done a whole big gob of those things before. Rate times time equals distance. And so what happens? The 165 is the constant speed of the plane. If it has a tailwind, what's a tailwind doing? Make it go faster or slower? A tailwind's going to make it go? No. Actually, a tailwind's pushing the plane and making it go faster. So a tailwind is going to make the plane go faster. A headwind is going to make it go slower because it's pushing against the plane and making it go backwards with that one. And we know the distance for both of these is 725. So what do I know about my two pieces of information in here? Well, do I know anything about the time factor? What do I know about time? 2 hours more. So what that means is if I clocked this piece out and found out my time, which is 725 divided by 165 minus W, and this other one is 725 over 165 plus W, if I set this one, because it's going slower here, 725 over 165 minus W, minus the 725 over 165 plus W, the difference between those two is 2 hours worth of time. And so you have to be real careful with this one and making sure that you get your time. So it's the slower minus the faster to equal the difference in time. Okay? So you got to be careful with that one and make sure you get your stuff in there. Yes or no? Your head's swimming? A little? Okay. And again, practice the other stuff before you hop into these things, so, and work those through. All right. So that is today's stuff.